Welcome to Coach Eichner's Math. Today we'll be talking about parallel lines and proportional parts in triangles. So, looking at it, triangle proportionality theorem says that if a line is parallel to one side of a triangle and intersects the other two sides in two distinct points, then it separates these sides into segments of proportional length. So, long story short, parallel lines, they intersect the same two lines. It's going to make similar triangles, CBD and CAE, and it's going to cut it into proportional parts. So we can say CB over CA, or CB to CA, CB to CA is equal to CD to CE. Likewise, BA to CA is proportional to DE to CE. And then looking down below, CB to BA is proportional to CD to DE. And then the last one, BA to DE is proportional to CA to CE. So, looking down at example number one, how does this help us? There's a number of ways I could do this. My favorite way to look at it is I like to say 1 to 2 equals x to 8. Go ahead and cross multiply it. Say 2x equals 8 or x equals 4. Looking down at example number 2. This one's a little different, but I see ST and TV, right? I see SR and VP. So I'm going to say 5 plus X divided by 3, ST 2RS is equal to TV, 8 plus X, over PV, which is 4. Cross multiply, say 4 times 5 plus x equals 3 times 8 plus x. So I can say 20 plus 4x equals 24 plus 3x. I'm going to subtract 3x from both sides. That gives me x left. Subtract 20 gives me 4. So x is again 4. Flip it on to the next page. Looking at example number 3, my suggestion to you is you go ahead and try this one yourself. See if you can do it on your own. Example number 3, I'm going to say x plus 1 and x is proportional to 6 and 4. So I cross multiply and say 6x equals 4 times x plus 1. Which is saying 6x equals 4x plus 4. Going to subtract 4x from both sides. Say 2x equals 4 or x equals 2. Looking down at example number 4. RT is 10. So now before I do any math, I know that y must be 4. Which is part of my answer. And then they're asking us to solve for x. Well, I'm going to do it the same way. ST is 4 over, we'll do this one the same way. We'll say over 6 equals VT, which is 2x minus 1 over 9. So 36 equals 6 times 2x minus 1, or 12x minus 6 equals 36. Okay, so go ahead and add 6 to both sides. And I would say that 42 equals 12x. So 3.5 equals x. So now I've got both pieces that we're looking for. Go ahead and box these so it does not confuse the situation. I'm not setting a proportion, I'm just marking those as my answers. Likewise, proportional parts of a triangle can be used to prove the converse of this theorem. So looking at it, if a line intersects two sides of a triangle and separates the sides into corresponding segments, the proportional lengths, then the line is parallel to the third side. So this is working backwards. Instead of them telling us it's parallel and us using proportions to find a missing length, they're going to tell us the sides, and if it is proportional, then we know the lines are parallel. So, looking at it, EG is 15, EH is 5, LG is 12, and FL is 6. Well, that makes this whole piece over here 18. So the way I'm going to look at this, I'm going to say 5 over 15 equal to 6 over 18. Are those proportional? Well, let's see. The easiest way that I like to look at it is if I simplify 1 over 3 equals 1 over 3. So those are proportional. The other way I could do it is say 5 times 18 equals 6 times 15. So that's 90 equals 90. So that would prove proportionality as well. Either choice works, but one or the other must be done in order to prove proportional. Determine whether HL is parallel to EF. In this case, because the parts are proportional, we can say that those two pieces are parallel. So yes, they are parallel. Looking at example number 6. We're going to use triangle ABC to find x so that DE and CB are parallel. So what that means is x must make these sides proportional because that's our goal. So as I'm looking at it, AE is 22, AC is 30, and AD is 10. EB is x plus 4. So I'm going to go ahead and write, this must be 20 right there. So I'd say 10 over 20 equals 22 over x plus 4. Or 10x plus 40 equals 440. Or 10x equals 400. X must be 40. So 40 would be the number I plug in here to make that side 44 total, which would make sense. 1 parts to 2 parts, 1 part to 2 parts. Those sides are now proportional so that DE is parallel to CB. Looking on next theorem. A segment whose endpoints are the midpoints of the sides of a triangle. Let's go ahead and look at that tongue twister. Segment whose endpoints are the midpoints of the sides of a triangle. That means that my segment here are the midpoints. It cuts into congruent pieces. Then to the third side of the triangle, its length is half. So, because this segment is the midpoint, cuts into congruent pieces, the length of this piece is half of the length of this piece. So I would say x plus 11 equals 2 4x minus 5. I say that because this is half, so I have to double it to say they're equal to each other. So looking at it, it'd be 8x minus 10 equals x plus 11. Or I can say 7x equals 21, so x would have to be 3. So if I go plug that back in to prove it, 12 minus 5 is 7. 3 plus 11 is 14. 7 is half of 14, which is exactly what we can prove when we know that these two pieces are formed by a midpoint and a midpoint. So looking at the next part, we know it's a midpoint, which means that these two parts must be equal. 4y plus 6 equals 2y plus 18. So 2y equals 12, or y must be 6. So right there we've got our two pieces. Looking down at the last part, find the values of x and y. So again, this is 2 of this. So as I look at it, if the whole piece is 72, half of it would be 36. So 36 would equal 5x minus 2. Or I could say that 38 equals 5x, or x equals 7.6, or 7 3/5. Looking on to the next piece here, y. We know that this is a midpoint because it's marked congruent pieces. Anytime they're congruent, I can set them equal. So 2y plus 18 equals 5y minus 3. So 3y equals 21, or 7 equals y. Right there you have it, talking about parallel lines and proportionality within triangles. This has been Coach Eichner's Math. Thanks for watching, and hope you have a great rest of your day.